Hello everyone, welcome to Civil Engineering and Stuff. And in today's video, we are going to discuss numerical on the designing of traffic signal timing using approximation method. So in the previous lecture, we discussed about the basics of approximation method of traffic signal timing design, and also discussed about the design step. So in this video lecture, we are going to discuss about, we are going to do a numerical on the design of traffic signal timing using approximation method. So let me quickly just review the design steps for the design of traffic signal timing using approximation method. So in the designing steps, the step one was to find out the green time using the pedestrian signal timing using the formula GPA 7 plus WA divided by 1.2, where 7 was taken as the initial walk period and 1.2 was the pace of pedestrians that are crossing the road section. And through the green time for the pedestrians to cross the road section, we find out the red time. And after this red time is for the vehicles, right? And after that, through this red time, we find out the green time for the vehicles for the respective roads. And then using the green time that is having the higher value, we used to find out the green time for the other road by taking into consideration the traffic volume that is moving in the respective road section. And through that, we find out the overall traffic, the total cycle time. And we discussed about this in detail in the previous video. So it is recommended to watch that video first before jumping to the numerical. And if you watch, let us do the numerical. So the question is that we have to design this or we have to find out the total cycle time for the traffic signal using the approximation method. And like we are given the information about the road intersection with two roads, road A and B. The data that are given to us are, we are given the width of the road for each road, we are given the traffic volume, we are given the amber time and the number of lanes in each road. So let us first of all draw the diagram. Okay, let us solve it. So like always, I again recommend solving with me as we move ahead with the question. I recommend you have your calculator with you. Okay, and as we move along, at least if not the steps you have learned, then at least you should solve the numerical values. Okay, then only watching the video will be useful. Otherwise, like watching a numerical video won't be of much benefit. All right. So let us say that this is our road A, this is our road B. All right. Now the width of road A is 18 meters. So the width of road A is 18 meters and width of road B is 10.5 meters. So width of road B is 10.5 meters. The traffic volume in road A is vehicles per hour. So we have 900 vehicles per hour at road A and 350 vehicles per hour in road B, right? And the number of lanes in road A is 4 and number of lanes in road B is 2, right? So let's say if this is the divider, this is, let's say, is the divider. So the number of lanes in road A is 4. So this is 2 lanes, these are another 2 lanes for road A. So road A is 4-lane road, and if this is the divider for road B is 2 lane. So we have lane 1 here and lane 2 here, right? So road B is 2 lane. All right. The traffic volume in road A is 900 vehicles per hour. So the traffic volume in road A we have 900 vehicles per hour, and number of vehicles in road B we have 350 vehicles per hour. So we have 350 vehicles per hour. All right. Amber time 5 seconds. That is given to us. All right. So this is the scenario. We have road A of 18 meter width, road B 10.5, vehicles moving 900 here, 900 here, and 350 here, and 350 here. So the first thing that we are going to do is we are going to find out the design volume per hour per lane on these two roads. The first thing that we are going to do is we are going to find out the design volume per hour per lane. We are going to consider traffic volume for each lane on the two roads, that is road A and road B. So design volume for road A. Now see here in this question we are given 900 vehicles per hour from both sides, right? Suppose in the question, if in one road the traffic volume was, let's say, 350 vehicles per hour, then we are going to adopt the higher value. So higher value is 900, right? So in case we have two different traffic volume data for a road, they are going to adopt a higher value. So here the traffic volume is 900 that are crossing from each side, right? That are crossing from each side, 900 here, 900 here. So we are going to find out per lane, right? So considering this side has two lanes, right? So 900 divided by 2. This will be equal to 450 vehicles per hour per lane. Okay, I hope it is clear to you. Like in the question, we are given that the traffic volume that is moving is 900 vehicles per hour. So basically, what it is saying is that on both sides of the road, on both sides, right? It's a two-way, two-lane road, right? So in this way, we have 900 vehicles. In this way, we have 900 vehicles. These 900 vehicles are moving in these two lanes, right? So we are finding out how much traffic volume is moving in a single lane. Okay, so that is why we have divided by 2, not by 4, right? I hope it is clear to you. If not, you can always ask. Okay, I'll again repeat just for the sake of like understanding that we are given that both sides of the road, both ways, we have 900 vehicles per hour. So in this side of the road, we have number of lanes 2. In this side of the road, we have number of lanes 2. On and all, we have 4-lane road, right? So that is why, considering the one side, we have taken 900 divided by 2. If it would have been another value, let's say here, if it would have been, let's say, 950, so we would have considered this side of the traffic volume that is moving in these two lanes, right? So that is why here, since 900 vehicles are moving each side, so we have taken 900 divided by 2. So that is 450 vehicles per hour per lane. Traffic volume in road B, each side, this is lane 1, this is lane 2, this is from left to right, this is from right to left. So in this case, since this 350 vehicles is moving in one lane, this is also moving in one lane, so 350 divided by 1. So this will be 350 vehicles per hour per lane. Okay, this will be 350 vehicles per hour per lane. All right. So we find out the traffic volume per hour per lane. This is how we are going to take up the traffic volume data. Traffic volume per hour per lane is the unit in which we are going to take the traffic volume. All right. So let us start with the designing. So let us go for step 1. So if you remember, the step 1 was to find out the minimum green time with respect to who? With respect to who? Minimum green time with respect to who? Pedestrian. In approximation method, we take pedestrians as a reference, right? So the minimum green time for road A, what was the formula? The formula was 7 plus width of road A divided by 1.2. So 7 width of road A is 18 divided by 1.2. Now you may have a doubt that since we are considering only one section of the road, why are we taking full width of the road? You may some of you may face this doubt. The reason why we are considering the whole width is because this is with respect to pedestrians. Remember, this is with respect to pedestrians, and we want pedestrian not we want pedestrian to cross the whole width of the road, right? Not here, half of the width. We want this pedestrian to cross the whole width of the road, and that is why we are considering the full width of the road. Clear? So this is 18 divided by 1.2. So if you solve it, the answer will be 22. Unit will be seconds. Never forget the unit, right? Likewise, for GPB, try to solve it by yourself. 7 plus WB divided by 1.2. 7, what is the width of road B? Width of road B is 7.5 meters. So it will be 7.5 meters divided by 1.2. So this comes out to be 13.25 seconds. Set your calculators to like 2 decimal places. It will be easy for like uniform answer. So we can assume it as 14 seconds. Okay. So we have through the step 1, we have find out the minimum green time for the pedestrians with respect to the width. Alright. That is your step number 1. Now what is your step number 2? What is the step number 2? Step number 2 is that with respect to the green time for the pedestrian, what will be the red time for the vehicle, right? And we have discussed previously, in detail. I will just go through these concepts in a very fast way. For detail, you can refer to the previous theoretical concept video of the approximation method. Alright, so in the step 1, we have found out the green time for the pedestrians in the respective roads. This is A, this is B. Green time for A, for this pedestrian to cross this side, for this pedestrian to cross this side. So if this pedestrian is crossing the road A, that is right now we have green for pedestrian at A. So this when there will be GPA, so this pedestrian is allowed to cross the road, right? So when the pedestrian is crossing the road, so there will be any vehicle moving in the road A? When the pedestrian at road A is crossing the road, will there be any vehicle moving in the road? The answer is no, right? Because we want safe passage for the pedestrian. So the green time for the pedestrian at A will be equal to the red time for the vehicle at road A, right? So the GPA is 22 seconds. So RA will be equal to, or the red time at A will be equal to 22 seconds. Likewise, if we use the similar concept, green time at B will be equal to red time for the vehicle at road B, which is equal to 14 seconds, right? So taking this red time, these are for vehicles. Both red at A and red at B are for vehicles. So taking these red time, we can find out the green time for in the respective roads for vehicles, and that formulates to our step number 3. Our step number 3 is to find out the minimum green time for traffic. So at road A, the red time at road A is equals to 22 seconds. Red at A, the red time at A, that is the vehicles at A are not allowed to move. This means the vehicles at B are allowed to move, right? So if it is red at A, so this means there will be green at B plus amber at B again, right? Red at A will be equal to green at B plus amber at B. I have discussed this concept in the previous video, so like you can watch that video for like a written description. All right. So this 22 seconds will be equal to green at B. Amber time is given to us as 5 seconds. So green at B will be equal to 22 minus 5, right? So 22 minus 5 will be equal to 17 seconds. Likewise, red at B, which is equals to 14 seconds, red at B, which is equals to 14 seconds, is equals to green at A plus amber at A, right? When it is red at B, this means the vehicles are not allowed to move at road B. This means the vehicles are allowed to move at A. That is, they will be green at A and amber at A. So green at A will be equal to 14 minus amber at A, 14 minus 5. So this will be equal to 9 seconds. This will be equal to 9 seconds. Right? This will be equal to 9 seconds. So what we have done is, up till now, what we have done is taking the green time for the pedestrians at the respective roads, we have found out the green time for the traffic or for the vehicles at the respective road, right? This is step 3. So in step 4, what we are going to do is, we are going to consider any one of the green time that we have found in the step 3, and using the relation GA by GB is equal to NA by NB, where NA and NB are the traffic volumes at the respective road. Using this relation and taking any one of the green time, we are going to find out the green time for the other road section. Correct? So which green time we are going to take? We are going to take the green time of the higher value. That is, in this case, is the road at B. So taking the green time, taking green time B equals to 17 seconds, because it is the highest of the both. We are going to find out the green time at A. So GA by 17, traffic volume at road A. What is the traffic volume at road A? We have calculated during the initial time. Traffic volume at road A is 450 vehicles per hour per lane. Traffic volume at road B is 350 vehicles per hour per lane. Putting this value, 450 divided by 350, right? So through this, we are going to find out the green time, that will come out to be 21.86, that we can take as 22 seconds. Okay. So just for your sake of information, I am just going to demonstrate what will happen if we take the smaller green time, that is the A in this case. If we consider green at A, that is the smaller one, which is equal to 9 seconds, then what will happen is, this means we are now going to find out the GB, green at B. So GA, that is 9 divided by GB, is equal to 450 divided by 350, right? And you see that our GB is coming to be 7 seconds. You will observe our GB will be coming as 7 seconds, which is much smaller than what we have found in the previous step number 3. So that is why we never consider the smaller green value. We always consider the higher green value that we in the step number 3. All right. So in step number 4, we have find out the green time for road A, taking the green time of B as 7 seconds and considering the traffic volume. All right. So what is the total cycle time in step 5? In step 5, the total cycle time T will is equal to GA plus amber at A plus GB plus amber at B. Green at A is 22, amber time is given to us 5 seconds. If it is not given, you can assume 5 seconds as the amber time. Green at B is 17 seconds, amber at B is 5 seconds. So the total cycle time will come out to be 49 seconds. The total cycle time will come out to be 49 seconds. Alright, clear? Okay. So if we draw this in terms of phase diagram, so let us draw this in terms of phase diagram for both type of traffic, that is pedestrian as well as vehicles. So we have road A, we have road B, we have road A, we have road B. So this phase diagram is for traffic or for vehicles, right? This phase diagram is for pedestrian. All right. So first of all, let us look for the traffic, right? The green time at A is 22 seconds, amber time is 5 seconds, right? So the green time for A is 22, amber time is 5. This is the green time, 22 seconds, and this is the amber time, 5 seconds. All right. So when there is green and amber at road A, there will be red at road B, right? There will be red at road B. So this will be red at road B, that will be equal to 27 seconds, all in terms of traffic. Likewise, we have green at B as 17 seconds, green at B as 17 seconds, and amber as 5 seconds. Green at B 17 seconds, and red at B, amber at B as 5 seconds. So when this happens, so it will be when there is green and amber at road B, we will have red at road A, right? This is for the traffic. Now talking about the pedestrian. So if you see here for road A, right now at road A, during this phase, we have green and amber. This means the traffic is moving, vehicles are moving during this phase. So of course, the pedestrians are not allowed to move during this phase. So this will be do not walk period for the pedestrian, right? This will be do not walk period for the pedestrian at road A. Right? This will be do not walk period, because right now during this time the vehicles are moving, right? So if I say what will be the do not walk period? What will be the do not walk period? The do not walk period. The do not walk period for A will be green at A plus amber at A. So that will be how much? 22 plus 5, that is equals to 27 seconds. This is equals to 27 seconds. Likewise, do not walk period for B will be equals to, so this is for the pedestrian at road B. In road B, during this phase, the vehicles are moving. During this phase, the vehicles are moving. So this will be do not walk period for B. So do not walk period for B will be 7. This will be green at B plus amber at B. So we have 17 plus 5 equal to 22 seconds, right? So this is your do not walk period. Do not walk period. Right? This is your do not walk period. So we can say this is your step 6. I think in the when we were discussing the step 5, step 6, yeah. When we were discussing about the theory, yeah, step 6 was do not walk period. Then we have the clearance interval. The clearance interval, that is step 7. Clearance interval is kind of a amber time for the pedestrian. That is equals to width divided by 1.2 meter per second. That is what we have discussed previously, is the pace with which a pedestrian moves, right? So talking about the 7th step, the clearance interval. The clearance interval for road A. Just like amber provides an extra time for the vehicles that are moving to clear the road, in a similar fashion, clearance interval also provides an extra time for the pedestrians to clear the road. So we have width of road A divided by 1.2 meter per second. That is the pace with which the pedestrian moves. Width of road A. What is the width that is given to us for road A? Let me just look into it. Width of road A is given as 18 meters, right? Again, like why we have considered the full width, because we want our pedestrian to cross the full width of the road. So we have 18 divided by 1.2, so that will be 15 seconds, right? So this 15 seconds is part of the kind of the amber time for this, right? So this is your clearance interval for road A, right? That is equals to 15 seconds. That is equals to 15 seconds. This one. Clearance interval for road B. Width of road B divided by 1.2. The complete width of road B is 10.5 meters divided by 1.2. It will be 6.25, which is equals to 7 seconds. So clearance interval for road B is 7 seconds. This is clearance interval. Should not be here. After you can write. Clearance interval is 7 seconds. This is the clearance interval. That is the 7 seconds. Okay. So what will be the walk period? What will be the walk period for pedestrians? What will be the walk period for pedestrians? So walk period for road A. Can you tell me what will be the walk period for road A? So the walk period for road A, if you look here, the walk period is when we have red at A, that is there is no vehicle that are moving at A, minus the clearance interval. That is walk period means the green time for pedestrians at A. So we have red at A minus CI at A. So that will be 22 minus 15 equals to 7 seconds. So this will be the walk period for road A, that is equal to 7 seconds. Walk period for road B. Walk period for road B, this part will be equal to when it is red at B. When it is red at B, This means the vehicles are now not moving minus the clearance interval. So this part. So we have red at B minus clearance interval at road B. So that is 27 minus 7 equals to 27. Okay, that will be equals to 27 equals to 27. Okay, so this is how the complete design of traffic signal timing using the approximation method is done. Okay, okay. So I hope this lecture was clear to you. Make sure when you are doing, you make a very clear and neat and clean page diagram. Okay, since I'm doing in a faster way, so it might look a bit hodgepodge. Okay, but we should draw it in a very clear way. All the ideas remain the same. Right. So I hope the video lecture is clear to you. If you have any doubt regarding this method, you can always ask in the comment section. Right. And try this numerical by yourself. And if you face any doubt or any problem, don't hesitate to ask in the comment section. Okay. And if you have found this video useful, and if you are a regular viewer of the channel, do consider subscribing to the channel, like this video, and like post reviews in the comment section. Thank you for watching. Have a nice day.